All right, so right now you're working on the do now. You're showing me an example of each of these. I'm just turning it around, looking at it. We want this picture you're using different things. So you're saying all of these sides are the same, like all of these sides. So when you look at like A, B, and B, X, Y have one slash, but then Y, Z, and two, so we can see this too. And then you see what I'm saying? So we want to make the slashes look different for the corresponding sides. Okay. Here, Tabby.
Alright, your account, how much you're off. So it's logged now, because now it's put in the password.
Yeah, that's okay. Tabby, oh, shit.
Yeah, but it's true.
So far, so good. So from good. Okay.
Yes, I wanted.
Mr. Day, see, please check my unit. So this is side, that's side, angle, side. The last one is angle, side, angle, so we don't want any more. So I have to put these over, we can, for angle, side, angle, we just want to have. And then you want to make the angles have different markings. So wait, so can I get rid of this one then? Oh, I didn't even notice that yet, because I didn't know if you were meant to put all of them in that. No, only the three of them. Yeah. And then for this one, see how you marked all four angles the same? Only 2 and 2 should be the same. So A and X should be the same, but then C and Z should have like a slash through the loop to make it look different. Because they're different angles, they're different angles, exactly. Now that's perfect. That's what's on the side. So you did angle, angle side, or side angle. The side has to be sandwiched between the two. No, SAS is perfect. The angle is in between the two sides, but for the side has to be in between the two angles marked. And see how AC would be between the two angles, A and C. Yeah.
Alright.
There. The same thing I was telling everybody else is you have to mark differently. So you're showing that all 6 sides are all the same length. That's not true. No, now you're showing that the two triangles aren't converting at all. So we want to show the sides that correspond. So if AB has 1 slash, then 6Y should have 1 slash. Then AC should have 2 slashes. There you go. Yeah. And then now fix the other problems. Same thing. Good. And then for this, one of the angles has to be different, right? So B and Y are the same, but then we have to make C and Z different by putting a slash through it. No, not the side. Yeah, come on. Yep, right through there. Yep. No, those ones are the same. There you go. Does that make sense? Okay, so you did, this is supposed to represent side, side, side. You did angle, 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 and then side, side, side. That's different. So what you want is 3 sides of one triangle congruent to 3 corresponding sides of another triangle. So if XY has 1 slash, then we'll say AB has 1 slash. Z has 2 slashes, then AC should have 2 slashes. YZ has 3, then BC should have 3. Now show me side angle side. Wait, so sides are like some for an angle? What are you talking about for like which angle? Okay, so pick one, so it's a side and then an angle and then another side. Yeah, so then which one does that match with on the other triangle? Yeah, and now you need an angle. That can't be, because for a side angle side, this angle has to be in between, sandwiched or made between the two sides. That would work, and then this one would A match with. Yeah, and now you use that other side that makes the angle with a angle. Yeah, and then, but now we have to put a different mark, so it'll be 2 slashes to show that it's different from the other sides. There you go. And now this one's angle side angle, so it has to be an angle, then a side in between, and then another angle. Yeah, that's good, and then it matches that one, yeah. That side's not gonna be in between. Um, either one, would be good. Yep. And then we need one more angle that thing on that side. But see, now that side is not sandwiched between the two angles, right? These are really, we have to be the angles. Like for example, I know it's just, I don't know if it's, yes, there you go. I'm like, wait, but I'm like, so I mean, I check your. Oh, yeah, we said we were trying the marking.
Like, I don't know. I just had that same because I was thinking of like differently.
Yeah.
Besides, since I would be like in number 2. Yeah. Not like I know them then. Oh, wait, a big because when is this? See, it's in that angle B. Oh, you're switching it up. You're saying these 2 words. I'm not trying it works. I love it. You're good. Were you good? I don't know. Okay, so did you watch the video? Yes. Okay, so for side, you want to have 3 sides of one triangle compared to 3 sides of another. So, no, you forward, pick your pen. Okay, so side, 3 sides of one compared to 3 sides. So choose your first slash. Now you're gonna pick a side on the other triangle and put one slash on it. Those are gonna be the one side together. And then now you pick a second side and put 2 sides. So that's different. And now, yeah. Basically, yeah, that's exactly what you're trying to do. That's a side for this side and how far is the side on this. And you need one side, just a side. But then now you can diagram to go right next to that. What it is. Oh, today's the first day we're doing it for 30. Never done that. Just like that. What should I not like that? Like, and now the other side wasn't based on margins. Yeah. That's the side angles. And now this one is gonna be 2 angles in one side. Yeah. And now we can't do this one, would have to be 2 hooks or a loop with a slash. Up to you. Yeah, perfect. That's it. Is there's no right in this way. The data was right. And we said that we see is better to see you don't mark that. But it's definitely one. And the way we control those people is one of the 3 methods from the top. So it's sense of size, side on the side, or in those times we put it. And we go with the market. So which one is this? Yeah. All right, guys. So today's lesson, last lesson, we were practicing proving triangles congruent and what it means, showing the markings, doing all that good stuff. Today, we're actually going to prove triangles to be congruent. So for the do now, just to recap, if I didn't get to check yours personally, the side, you need 3 sides of one triangle congruent to 3 sides of another triangle. But remember, the sides that match up have to have the same marking. So if I put 1 slash on AB, I'm going to put 1 slash on XY. If I put 2 slashes on BC, I have to put 2 slashes on YZ, which means the last side has to have 3 slashes. I can't do them all with the same slash. And then side, angle side, if you remember, we have to have 2 sides, but then the angle needs to be sandwiched in between the 2 sides. And the last one is angle side angle. So you need 2 angles and the side has to be sandwiched in
between the two angles. And there could be different variations of B and C. There could be different variations. Yours doesn't have to look like how mine looked. Okay, so today we're proving triangles congruent. And remember, there's only 3 ways to prove triangles congruent. Side, 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 side angle, side, or angle, side, angle. Those 3 ways. So when your statement says triangles are congruent, your reason has to be one of these 3. So when your statement is triangles are congruent, your reason is one of those 3. And we don't know which reason it's going to be until we go through the whole proof. This is why it's so important that we mark our diagrams. So it says segment AB is congruent to segment ED. Segment AC is congruent to segment EC. But then it says C is the midpoint of BD. If C is the middle point of segment BD, who remembers what we can conclude from that? Stella?
That BC and CD.
Good. We can conclude that segment BC, so I'm going to write that down, segment BC is congruent to segment CD, and our reason here will be def of midpoint. Because it was the midpoint in the given information that told us that we're going to mark those congruent. So now we look at our triangles, and these 2 triangles are congruent by which one of these? SSS, SAS, or ASA? Look at the markings. Which one is it? SSS. So then we say that these are congruent by SSS. Okay, next one. First step is always our given. Is it important to mark your diagrams correctly? Absolutely. So it says angle 1 is congruent to angle 2. So remember, we mark angles with a loop. And then we have segment EF is congruent to segment HF. So I put a slash on each of those. Now, our last step is always what we want to prove. So my last step is going to be triangle EFJ congruent to triangle HFG. And remember, our reason is either going to be side, 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 angle, or angle, side, angle. And we won't know until we fill in the whole proof. We won't know which one it is until we fill in the whole proof. So we're missing our second step, which is going to be the deciding factor for us. We already have one angle and we have one side. Does anybody see anything else that's congruent here?
Angle 3 and 4, because they are vertical.
You got it. So we can say, we can mark it first. And we're going to say angle 3 is congruent to angle 4. Who remembers the full theorem that we write down for this? Caitlin? Excellent. Vertical angles are congruent. Now that we filled in this whole proof, now we're on our last reason and we have to look at our markings. What do the markings say? Is it SSS, FAS, or ASA? ASA, 2 angles and the side in between, ASA. All right, next one. So I'm going to mark everything we have. Angle R is congruent to angle N. RP is congruent to NT. RT, look how I mark this. RT is congruent to NP. And TS is congruent to OP. And we're proving the triangle's congruent. So we are proving triangle NOT, this yellow one, congruent to this yellow one. Now, I'm missing my second step here in this proof. Do you guys see how the big TR is congruent to the big NP? And then this little part is congruent to this little part? So I can say right now that SR is congruent to OP. Oh, sorry, ON. Can anybody tell me why I'm able to say SR is congruent to NO? Stella?
Well, because we marked up that like NOP and RST are all congruent, and we marked up that the smaller part of it is congruent, so that the bigger, like the other part of it has to.
What is that? One word.
Oh wait. Triangle.
No. So the big TR is congruent to the big NP, and then little TS is congruent to little OP. So now we're left with NO congruent to SR. Subtraction, you got it. And now looking at your markings, Sebastian, the triangles are congruent by which one here? Look at our marks. How we mark things. Well, look at the yellow triangle. I only have one angle, right? You have this, and then you have that. So what is that? Your options are SSS, SAS. You got it. Is anybody confused with how Sebastian got SAS? Why we got that? We're good? Okay. So we have that segment CD is congruent to segment DE. Segment BC is congruent to segment EF. And angle 1 is congruent to angle 2. And this is nice. In step number 2, they're telling us that the whole BD is congruent to the whole DF. And we just have to write down the reason why. Who thinks they know why based on our markings? Why BD is congruent to DF? Not Stella or Leilani. Noah. Addition, excellent.
I have a question.
Mm-hmm.
So for the third statement, would like, cause I remember you said like when like it's not like the line, I can. So say for example, DG, can we say that's like reflexive because we can use it for like both of the triangles?
Very good. That's exactly what we're going to do. So now for everybody else, let's look. Leilani got ahead of us, but we're trying to prove the triangle. So our last one is what we want to prove. So triangle BDG is congruent to triangle FDG. And our reasons have to be either side, 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 or angle, side, angle. Now, what we have right now, these are the yellow triangles. Through the addition, we got the full side BD congruent to the full side FD. We have from the given angle 1, angle 2. So that's just one side and one angle. We need another something. So Leilani said, see how DG is the same side in both the triangles? We say anything is congruent to itself. So we are going to put an X here and say that DG is congruent to DG, and that's the reflexive property.
Wait, is it reflexive because you can use it for
Yep, because we can use it for both, aside for both triangles. So Jack M, what method are these triangles congruent by? Excellent, SAS. Okay. I want you guys right now to mark your diagrams correctly with the given information, and I'm going to come around to look. Okay, so what do we have? We have GH. So this segment only is congruent to this segment only. So I'm going to put a slash there, slash here. And then we have HM. Now this one's a little bit tricky since they're a little bit overlapping. So what I'm going to do is I'm just going to highlight it. So this whole segment is congruent to this whole segment. And then we have GO is congruent to KM. And now it's leading us through. Right now, the triangles we're proving, I will highlight in green or blue, highlight in blue, is this triangle right here. And then in green, I have this triangle right here. So we have those two triangles that we're getting, that we're proving congruent. So do you guys all agree that OG and MK is a full side? And OJ and MH is another full side? But GH and JK, they're not full sides. They're too small. They're too short. They're not a full side. So that's the part we're trying to figure out how to get the full side. So they're saying, well, step number one is our given. And then they're saying, okay, well, I need to go from GH to all of GJ. And I need to go from KJ to all of KH. To get from these small parts to the bigger parts, I need to use HJ twice. And when you use something twice, that's the reflexive property. So they're saying HJ is congruent to HJ, reflexive. And then I had GH, but I'm going to GJ. And I had KJ, but I'm going to KH. So I went from small to big. What is that? Small to big is addition. And now our last statement is to prove the triangles GOJ congruent to triangle KMH, and it is SSS, side, side, side. Okay, two more together, then I'll have you try one on your own, and then we will call it a day. Okay, so in the given information, it says that SV bisects angle TSB. Bella, what happens when you bisect an angle? Good. We get two congruent angles. So this is a point where a lot of students mess up. Where are the angles going to be congruent? So it says that we're bisecting angle TSB. So you go to the middle letter S and then you look inside. Inside of S, do you see two angles? Yeah, I'm going to call them 1 and 2. Those are going to be the two angles that will be congruent. So statement 2, I'm going to say angle 1 is congruent to angle 2, def of bisect. What did you do? Did you put the angle symbol in front? Then you're perfect. All right, then it told us that ST is congruent to SB. So I mark that. All right, and now they're saying our reason is the reflexive property. So what do you think they're going to be saying? What is being shared between both triangles? Jonah? SV, you got it. So we're going to say SV is congruent to SV reflexive. And now lastly, our triangles will be congruent. And remember, when the triangles are congruent to either SSS, SAS, or ASA. Maya, which one is this? Perfect, SAS. All right, one more together, then you'll try one on your own, and then we will be done for the day. Okay, so here it says that RO is perpendicular to MP. Jaxie, what does that mean if RO is perpendicular to MP? What can we conclude?
They are like is it 90-degree angles?
We make right angles, exactly. So if RO is perpendicular to MP, then we're going to get two right angles there. So in step number 2, I have to write that they are right angles. So I'm going to say angle 1 and angle 2 are right angles. And what part of the given told us that they were right angles, Jack? You got it. It was the perpendicular part. So we're going to say def of perpendicular. And then naturally, after we declare right angles, we always have to say that those angles are congruent. So step number 3, I'm going to say angle 1 is congruent to angle 2. And the reason is right angles are congruent. All right, so that was all just from the first piece of given. Now I'm going to go to the second piece of given. It says angle MRO, so I have to mark that. Angle MRO is congruent to angle PRO, so I mark that. All right, and our last step is to prove the triangle's congruent, so we know it's going to either be SSS, SAS, or ASA. But we're missing one step. We just have two angles. So we definitely need a side. Anybody see how we can get a side? Jack? Excellent. RO is the same in both triangles. So we're going to say RO is congruent to RO reflexive. So then the triangles are congruent by what, Sebastian? It is perfect, ASA. Okay, you guys ready to try one of these on your own? All right, let me see which one I want you to do. I want you to do number 9 on your own. So you skip number 8, you're going to do number 9 on your own. And then I will check it, but we will stop recording here.